Alright, so hyperbolas, our objective is to be able to graph a hyperbola given its equation. A hyperbola is a set of all points in a plane. The difference of whose distances from two fixed points is a constant. Alright? So these two fixed points are the foci of the hyperbola. So the idea behind this is if I had this, we call this distance A and this distance B. If I subtracted A from B, right, and then I picked another point. Let's say I pick a point down here, and we have its distance, right, and we call that C and D. If I said, so B minus A is going to equal to D minus C. Okay, it's absolute value. You could do A minus B equals C minus D and do the absolute value. Anyways, the absolute values is going to, the differences is going to be the same. If the hyperbola is horizontal, then the x-intercepts are A, and the points A0 and negative A0 are the foci, are the vertices of the hyperbola. If there is no y-intercept, there is no y-intercept, right? So A0 and negative A0 would be the vertices, of the hyperbola. That would be this point and this point are the vertices of the hyperbola. There's no y. The hyperbola consists of two parts called branches. The segment joining the two vertices on the separate branches is the transverse axis of the hyperbola. So this is the transverse axis, and the origin is called its center. And then we have asymptotes. The asymptotes are lines that the hyperbola approaches for large values of x and y. So your asymptotes are going to look something like this. These lines, and we'll learn how to draw those in. All right. Any questions on the terminology? All right, here's the summary of the hyperbola then. So now the hyperbola is x squared over a squared minus y squared over b squared equals 1. A is going to always be greater than b. Okay, so then the other way it would be is y squared over a squared minus x squared over b squared equals 1. So the larger number is always going to, on the bottom, will always come first. That determines whether x squared or y squared is first in the equation. So that we have the vertices, and then we have the transverse axes. The length is 2a. So asymptotes. The asymptotes are for when the horizontal axis is the x-axis, is y equals positive negative b over a x, and if it's vertical, it's y equals positive negative a over b x. All right. the foci is positive, negative C0, and positive, negative, and then for the one with the vertical, that's on the vertical axis, it's 0, positive, negative C. Now, and then determining C, now C squared is A squared plus B squared. So you have a bunch of similar things you use, except you have to remember the difference. In the ellipse, it's C squared equals A squared minus B squared. In a hyperbola, it's C squared equals A squared plus B squared. Alright, so we'll come back to that summary. Asymptotes are essential aid for graphing a hyperbola to help us determine its shape. A convenient way to find asymptotes for a hyperbola with a horizontal axis is to first plot the points A0 and negative A0, 0B and negative B0. Then sketch the horizontal and vertical segments through these points to construct a rectangle. As you can see here, you construct this rectangle. This rectangle is called the central box of the hyperbola. The slopes of the diagonals of the central box are, you can know it's rise over run, right? So that's B over A, positive, negative B over A. So that's, I just go through the corners of my central box to draw my hyperbola. Then we plot the vertices. So we put the vertices here, and then use the asymptotes as a guide for sketching the hyperbola. So then you sketch in your hyperbola. The hyperbola is never going to touch the asymptotes, it just approaches it. So you sketch that in as like that. Alright, any questions there? Yes?
Well, the hyperbolas have to be exact.
No. It's a sketch. Alright, so here's the steps. Sketch the central box. Sketch the asymptotes. Plot the vertices. Sketch the hyperbola. Let's look at an example. A hyperbola with a horizontal axis. Okay? The hyperbola has the equation 9x squared minus 16y squared equals 144. So it's going to be horizontal because the A is under the x, right? That's the larger value. So you start out with 9x squared minus 9x squared minus 16y squared equals 144. We divide by 144, we get x squared over 16 minus y squared over 9 equals 1. So BA is 4 and B is 3. So the vertices are going to be positive, negative, 4, 0. And the foci, then we have to determine C for the foci, right? We've got A squared plus B squared equals C squared. So that's going to be 16 plus 9 equals 25. So C equals positive and negative 5. Right? So my foci is at positive, negative 5, 0. Right? And then if it's a horizontal hyperbola, I know that because the x axis is the major axis, the vertices are on the x axis, so I'm going to use the equation. You just have to remember that's going to be y equals positive and negative b over a times x. So then the asymptote is y equals positive negative 3 over 4x. Right? Everybody has it? Everybody got it? Alright, so then we'll graph it. I'm going to graph my central box. The x values are 4 and -4, so I'm going to draw lines there. The y values are 3 and -3, so I draw my lines there. Right? Doesn't have to be exactly a box, you just draw the lines. And then, so then I draw my diagonals through the origin and the corners of the box. Okay, my vertex is at positive -5, 0. So here we've got -5, 0. Here we've got 5, 0. And then that's our foci, which we determined. And then we can draw in our hyperbola. Remember, the foci are not the bottom point of the hyperbola. It's the vertex. It's 4 and -4, 0. So then we've got the other side, and then the equations of the equations of my diagonals are y equals -3/4 x and y equals 3/4 x. So I've drawn my hyperbola. Any questions there? No questions. Okay. Let's do another example. If I have this written down. Alright, moving on. Hyperbola with a vertical transverse axis. Okay, so we've got x squared minus 9y squared plus 9 equals 0. So we're going to have x squared minus 9y squared equals -9. So we divide by -9, and we're going to get y squared minus x squared over 9 equals 1. Right? So the a, in this case, is going to equal to 1. Right? The y comes first. So the a is 1. B is 3. And c is going to equal to the square root of a squared plus b squared. So it's going to be 1 squared plus 9 squared. Oh, not 9. 1 squared plus 3 squared. Which is equal to the square root of 10. So our vertices are at 0, positive, -1, and our foci are going to be at 0, positive, and negative, radical 10. So then my asymptotes are going to be, since it's a vertical, it's going to be y equals positive and negative a over b x. So that's going to be y equals positive, negative. Okay, a is 1, b is 3, 1 over 3 x. Yeah?
How was A equals 1 and B equals 3? I thought B was A was the greater value.
Yeah, that must not be right. That's yeah, the greater value Oh, I said it wrong. They're greater than 0. I said it wrong. It's not A is not greater than B. They're both greater than 0. All right? So if the y, it's just, either one can be, it doesn't matter the size, it's just if the y is the first value, and if the y squared comes first, then it's going to open up or down. If the x squared comes first, it opens right or left. So, yes. I said that wrong. All right, so then if we graph this, so we graph our central box. The y values are 1. The y values are 1 and negative 1. The x values are 3 and negative 3. Right? And then we draw in our asymptotes through the corners of the box. We plot our foci, which is radical 10, which is 1, 2, 3, between 3 and 4. There's foci. And then we plot our asymptote. Let's do it in a different color. Let's do it in green. So our asymptote is going to be this line. It touches the central box at the middle point there. There's one, and there's the other, right? So there's your parabola. And the equations of, the equations of the asymptotes are y equals, this is y equals 1/3 x, this is y equals negative 1/3 x. Okay, any questions? Okay, I'm gonna have to go fast to get through the notes, so I'm gonna go really fast here to try to get done. Next example, we've got finding the equation of a hyperbola from its vertices and foci. All right, so we have the vertices are positive negative 3, 0, the foci positive negative 4, 0. So that means we know A equals 3 and C equals 4, right? So then we know for a hyperbola, A squared plus B squared, A squared plus B squared equals C squared. So that would be 9 plus B squared equals 16. So that means B squared equals 7. So B equals radical 7. So the equation would be x squared over 9 minus y squared over 7 equals 1. Right? That's my equation. A squared and B squared go on the bottom there. Alright? So, then we are going to sketch our central box. We've got the x values are at 3 and negative 3. The y values are at radical 7, which is between 2 and 3. And then we draw our diagonals in like so. And the hyperbola is the foci are at 4, negative 4. So I plot those 2 points. And then I draw in my hyperbola. Remember, it doesn't go through the foci. It touches the central box. There's my graph. Any questions on that one? All right. Then we have this last one. Okay, you guys on your way out, you can pick up some graph paper. I don't have time to pass it out. I'll put it right here. Get a sheet of graph paper. Let's do this last example. Okay, so on the last example, we've got find the equation of the hyperbola from its vertices and asymptotes. So the equation in the foci of the hyperbola, the vertices are positive, negative 2, and the asymptotes are y equals positive, negative 2x. Okay, so we have to use that. We know if it's a vertical hyperbola, then y is equal to positive, negative a over b x. So that means if the and we know that a from the where the vertex is, we know that a equals positive, negative 2. So we're going to say y equals 2 over b times x, right? And then it tells me the equation of the asymptote right here was y equals 2x. So that means that from that's 2x. So that means to make this equal to 2x, b would equal 1. Right? Everybody follow that? So we're 2b over x equals 2x, so 2 over b equals 2, so b has to equal 1. So then we do our equation. Since it's a vertical hyperbola, it's going to be y squared over 4 minus x squared. We determined that the b is 1, so it's x squared over 1, or just x squared, equals 1. And then we have to determine the foci. So that's b squared, a squared plus b squared equals c squared. So that's going to be 4 plus 1 equals c squared. So c equals radical 5. So our foci are 0, positive, negative, radical 5. Right? Everybody have all that? Okay, if you at least write it down, you can go back and review it if you don't understand it quite yet. All right, everybody's got that? Okay, so let's sketch this real quick. I think we can get it done. So my y values are 2 and negative 2 for my line of best fit. Come on. So we've got 2 and negative 2. And my x values are 1 and negative 1. So then I use that to draw my asymptotes. And then my foci are at positive, negative, radical 5, which is between 2 and 3. So there's my foci. Don't forget to plot those. And then we draw the hyperbola. It goes right there and right there. All right. Everybody got it? Okay, very good. So your homework is posted in Canvas. And don't forget we have a quiz over conics next time.